Good day, everyone. You're welcome back to another study session. In our different study sessions that we've done earlier, we've talked about the introduction to statistics, and we've gone a lot to talk about data collection, the different types of data that you have, and then why you need to do data collection. We went ahead and we talked about statistical inquiry, and we told you that when you're doing a statistical inquiry, you definitely will need to collect data. And you're doing the statistical inquiry with one thing at the back of your mind. You're trying to solve a particular problem, but before you can solve that problem, you need to have an idea of what the problem is. And for you to have an idea of what the problem is, you need to collect data to be able to solve that problem. Today we're going to be talking about statistical tables, because after you've collected the data and you have used you've used all the tools in your arsenal to collect data, you have the data in its raw form. How do you make sense of that data? How do you analyze the data? Do you just jump into analyzing this data, or you need to put this data in a particular format that makes it easier for you to analyze? In this study session, we'll be talking about statistical tables and how you can use statistical tables to organize your data and present your data in a more presentable format. So we'll start by giving a brief outline. Okay, we're going to talk about an introduction, and this introduction is to the entire study session, and then we're going to tell you about what a table is. We'll define a table and why you need to use a table. We're going to talk about the different considerations for putting up a good table, because just like everything you do in this world, you have to do it in a good fashion. You have to do it very well. So there are particular requirements or considerations that you have to put in place for you to have a good table, which is going to be presentable. Okay, and then we're going to come and talk about the different parts of a table, and for you to also know that when you are presenting a table, there are some particular parts that you have to put into your mind. Generally speaking, you have major and minor parts, but we're going to go into that in detail when we get to that particular area. We're also going to now hone in to the different types of tables, because there are so many different types of tables, and basically we'll talk about 3 types. And you're going to come across all of them if you're going to be doing statistical inquiry, or if you're going to be doing some form of data collection and data presentation, as well as interpretation of data. We'll give a summary and then we'll conclude. Okay, that's what we need to do. If you have not watched our previous the previous videos for all the other sessions, this is a really good time for you to do that, because you would need to have some, and you need to know the basics for you to be able to follow us here. Even though this lecture is going to be very simple, it's going to be straightforward, it's going to be short, but it will be good for you to do that. So I'm going to leave a link to our previous videos in the link above. You can click on it and watch it, and then I'm going to put also timestamps to the different portions of this video. You can click on the timestamp to go to any portion of the video. Let's get into the video. Generally speaking, you start the process by thinking of a problem. A problem is usually available. There are problems around everywhere, and they're just waiting to be solved. And statistics is one of the best ways in which you can use to solve problems. But for you to be able to solve a problem, you need to know the nature of the problem in the first place. Okay, and in the previous study session, we talked about you conducting a kind of statistical inquiry, which is in short, a kind of research that allows you to go take a deep dive into the problem, collect data, and understand what the issue is. So if you talk about a statistical inquiry, you are going to first of all have your goal, and the goal is actually to solve a particular problem. But for you to be able to solve that problem, you would have to collect some data. So you have objectives, and those objectives will help you lead to achieving your goal. Okay, and when you already know what your objectives are, you want to set out to go and collect data to be able to define and find out what your objectives get information about your objectives. All right, so you're going to go and collect data, and when you collect the data, you would want to organize this data first of all, because the aim is for you to make sense out of the data that you have collected. Okay, so after collection of the data, you have to organize this data, and then you do data analysis and then data interpretation. And once you interpret that data, you can now use it for decision making, which is the main aim of even studying biostatistics in the first place. You want to get data, analyze the data, make sense out of the data, use it to solve real life problems. We're not talking about theory here. It's practically oriented and real life public health problems. Okay, so when you do data collection and you collect this data. The data that you've collected is in its raw form. It's usually unwieldy. It's usually big. You cannot really do very much with it just by staring at it, just by looking at it. There's very, very little thing you can do with the data. Is you can't decipher, you can't make any sense out of that data. All right. And you can also jump into analyzing the data immediately. You have to organize it in a way that even tells you, gives you an idea of analysis. So data organization is like the midway between, it's on the pathway between data collection and data analysis. You have to first organize the data before you now analyze it. In fact, when you organize the data, it gives you a clue as to what kind of analysis you need to do. And you see that as we go along in our course. So when you collect this data, it is in its raw form. We say it's raw data. So it's raw in the sense that it is not processed. And since it's not processed, you can't make heads to tails out of it. You cannot do any good thing about it with it unless you put it in a format that allows you to analyze it and allows you to make very good sense out of it. So what you want to do is to organize it. First things first. After data collection, you organize. Although, yes, you have to clean the data, but when you clean it now, you now organize it in a format which is presentable for you, for yourself, and also for others. You can see it. And there are different ways in which you can do this. Okay? So there are different ways in which you can organize data. We're going to be talking about the different ways, but let's just give I just want to give you an example here. This is a study that was done. This is hypothetical, all right? So it's just some fictitious data. But just to understand the importance, why you need to organize data when you've collected it, because just collecting it enough gives you raw stuff that you can't do very much with, okay? So imagine you went to do, let's hope that the vaccination programs gear up and we're able to be at par with other countries where even children are already receiving vaccination for COVID. But imagine this was a study that was done, or a statistical inquiry that was done to determine the vaccine status of children, COVID-19 vaccine status of children in Zaire. And what you see on the screen here, what you can see is just data points of the vaccine status of children that we're able to find in the clinic when we went to, because the clinic-based study, okay, for example. Okay, so you can see not vaccinated, fully vaccinated, partially vaccinated. And guess what? What you see here, even though it doesn't even really, you can't make very much sense out of it. This is from 107 children just in one clinic. And what you can see here is not really, you can't say very much out of what you have seen. But this is just from one clinic. Let me show you what we got from the other clinic. Okay, so you can see the first layer and the background, and then the second layer. This is another 107. This is another 107. Another 107. Another 107. You can see that it's really, really getting already out of hand. Okay, so you can't make any much sense out of anything like this. This is all the data that you've collected. The only way in which you can make some sense out of this is by trying to organize it and put it in a particular format that makes it easy for anybody to even see at a glance and understand. I'm sure you will guess, if we're writing this on pieces of papers, you know how many reams of paper we'll have even used just writing the vaccination status. It's a simple variable that we're talking about here. It's just vaccination status. So if we see a child, are you vaccinated? Yes or no? And you know, COVID-19 vaccinations, a couple of them have more than one dose. If you are talking of Moderna or the Pfizer, for example, you have the primary dose is 2 doses, first of all. Okay, so if you have 1 dose, you are partially vaccinated. If you have 2 doses, you are fully vaccinated, for example. So we're going to see a situation where we have children that are unvaccinated, we have some that are partially vaccinated, and we have some that are fully vaccinated, for example. Okay, so in a situation like this, this is the kind of data that we have. How do we organize this data? How do we put this data in a way in which we can make sense out of it, and then we can further now move along to analyze it? Okay, so it gets really, really unwieldy. So when you're organizing data, you can organize it in one of 2 ways. It's either you organize it in a tabular form or you use graphical form. All right, the graphical form, we will talk about it in our next video, but this video series is just about organizing data in a tabular form. Okay, so you can do this in a tabular form or you can do this in a graphical form. We're going to concentrate on the tabular form, and we start by talking about a table. So a table is just a simple structure that is arranged in rows and columns, where you have data that you put in that stead to be able to make sure that you are able to visualize the data properly and organize it in a better format. So you have a definition that says a table is a structure that is made up of rows and columns that helps you to systematically organize and present raw data in a meaningful format. What do we mean here? We're saying this in a very simple format, that you have a structure that has rows and columns, and these rows and columns help you to strategically, or help you to use a method to organize data that you've collected, raw data that you've collected, in a meaningful format. Okay, and there are different types of tables. We're going to talk about that pretty soon. But you see a table that looks like this. It has columns. The columns are the vertical, you see the vertical ones, and then the rows are actually the ones on the horizontal. So row is like X and column is like Y, if you understand the XY notation. So it's just a simple structure, but it helps you to save space. It helps you to show your data in a very, very simple way. And it gives you a lot of chance to be able to do a lot of things after that. Okay, so what are the advantages of tables? There are so many advantages of tables, and I've mentioned a lot of them as I started this lecture. But the first thing that you need to know is that it helps you to easily understand the data that you have. All right, you remember the small graphic I showed you about different data points from vaccination status of children, and it doesn't make any much sense, but we can just put it in a simple table, and then it gives us easier understanding. In a simple table that just shows vaccination status, fully vaccinated, partially vaccinated, unvaccinated, and gives us the number. We know exactly what we're talking about. Okay, it also makes it easy to organize your data. So because once you organize the data, then you can compare the data with other. We can compare, we can know how many people were actually vaccinated. Can we compare the unvaccinated with the vaccinated? You know, so it's a very, very good way when you have a table, when you have data put in table, it's easy to compare and make comparisons with the different data points. Okay, it's also easy to analyze your data. Now, remember I said this is a midpoint between you collecting data and analysis. When you put data in table or in a tabular format, then it gives you some insights. You can see very well and know which analysis you do, what type of data, what data type is this, what kind of analysis are we supposed to do. In fact, it even helps you when you want to move to graphical presentation of your data. Okay, so and finally, I'm sure you all agree with me, it helps you to save space. So these are advantages as well as uses of tables. So if you're asked what are the uses of tables, you can just list all of this, or the advantages. It has a lot of advantage. Okay, so like with other things, tables have components. Okay, and we have major components and minor components of a table. So once you're doing a statistical table, then you have to put this in mind. Now, bearing in mind also that when we talk about a statistical table, we're not here in this lecture and in this series. When we talk about statistical table can mean so many things. But in this presentation, we mean just simple frequency tables or frequency tables or contingency tables and the rest. I'm sure you know there are other statistical tables like your 4-figure table, which allows you to look into some different Z table, T-test table, T-table, chi-square table. Those are also statistical tables. But this table I'm talking about is tables that you use to organize the data, not table that you look up to find a particular function or to get which number corresponds with some particular statistical entity. Okay, so there are different parts. There's the major part, and the major part has just 4 elements that you have to consider. These are the title. A table must have a title. A table must have what we call captions, and this captions is also known as box head. And this is just I would want to say it's like the heading of the column. Okay, you know the column are the ones is the one in the vertical arrangement, right? So each column must have a small heading. That heading is called a caption. All right, and then it's called a box head, or some people call it column caption. Now you can really you shouldn't mix this thing up, because C for caption, C for column. So you say column caption because you see some people saying row caption and then they mess the whole thing up. Okay, and then you talk about stubs. Stubs are for each of the row that you have. The row starts, the beginning of the row tells you what that row is about. Okay, so that first part of the row that gives you the label for that row, they're called stubs. Okay, and then finally you have the body of the table that contains the data itself. All these other things don't contain the data that you have. The title doesn't contain the data, it just has description of the data. All right, the caption also just describes what is in that single column. Okay, and then the stub also describes what is in that single row. All right, and then the body now is anything other than all these other things that you find that has the data that you're looking, that you're trying to organize. Okay, so these are the major parts. In general, there are 9 parts of a table. There are a little more, but these are the other minor ones that even though they are necessary, but sometimes you may not, it's not compulsory to have it in all tables. Okay, so the fifth one is which is a minor component, is an identifying number, and I'm going to show you some examples. It's just that number. For instance, if you have an article and you have 3 tables in the article, each table must be numbered so that you can refer to that table. So it's table 1, table 2, table 3, and the same thing with figures. You have figure 1, figure 2, figure 3. So I hope this is clear. All right, then the next thing is a footnote. A footnote sometimes helps you to explain what is actually inside the table, and you can use different notations within the table that you link to the foot of the table with the footnote. So you see star, single star, double star, triple star, and the rest like that. Okay, and then you have what is called a source note. This source note is if the data that you are presenting or the data that you are organizing, it's not from you, you got it from somewhere else. For example, if it's secondary data, we've talked a lot about secondary data. Last study session was about sources of data, where you have primary and secondary data. So primary data, you collected it yourself, no problem, you won't need to talk about the source. But secondary data, you collected the data from someone else, and the other people, you have to acknowledge where the data was coming from. Is it in a journal? Is it from a report? Is it from the Federal Ministry of Health report, or wherever this data is coming from? So that's like the source notes. Okay, so you have so many other parts of the table. You can see, as you can see there, we're not going to waste very much time on that, but just to talk about it, you have totals, and this is also not compulsory depending on the type of table you are drawing and depending on what you are trying to depict. Okay, sometimes it's not necessary for you to put the totals, especially if the variable that you are using is a multiple response variable, and I hope you know the totals will not make very much sense, but we're going to describe this a little more. The last but not the least, which you can see as the number 9 here, is the something we call the prefatory notes, or we call the head notes. So usually after the title, you can put a little small description that gives a little more explanation of the contents of the table. Okay, the title explains what's in the table, like it describes the characteristics of the table, right? But the prefatory notes gives you a little more detail, something that gives a general outlook of what is in the table. These are the parts of a statistical table. You have the title, you have the caption, you have the stubs, you have the body of the table, which are the major parts. Okay, and then like you can see, you have the identification number, or the identifying number, or somebody could say table number, or table number. And then you have footnotes, you have your source notes, you have the totals, and finally you have prefatory notes. Okay, so this is an example of a statistical table, and just to tell you the different parts. So firstly, you can see the title of the table. Okay, and so we're talking about the major aspects here. So you can see the title of the table. You can also see the captions. Here you see where it's written frequency and percent, and then you can see the body. All right, and then finally you can see the stubs. These are the four major parts of a table. So clearly seeing the title. Title should be descriptive. The title should tell you in time, person, and place what exactly are the contents of the table. And then you can also see the stubs. Okay, just close by here. The stubs are those for the labels of the row. You can see the captions. The captions are actually the labels of the column, and then every other thing else within this stuff within the table is actually the body. Okay, so let's look at the minor parts of a table. You can see now the table number, or the identifying number, right? And then you can also see the prefatory notes, okay, or the head notes, and you can see that it might not be necessary depending on the kind of information that you are giving out here, okay. And then you can also see the totals, which, like I said, is not exactly compulsory depending on the kind of data that you have, okay. And then you can see your source notes, you can see your footnotes, and this is basically what you have in a table as the minor parts of the table. So we now go into the requirements of a good table. For you to draw a table, put the table down and use the table for statistical analysis, and use the table as a guide to help you with statistical analysis, you have to fulfill some basic requirements. Number one is that the table needs to be simple and it needs to be compact. You don't want a table that is too large, difficult for people to understand. So it needs to be simple and it needs to be compact, okay? The next thing is that you should make sure the table is self-explanatory, right? It should be on its own without they needing to call you and say, excuse sir, please, I don't understand what is in this table. The table itself should just be simple. It should be self-explanatory, complete in its own self. I shouldn't be asking you, where was this data collected? You should have told me that this data was collected in Zaria. In the title, I should have seen that in the title, right? So this is very important, okay? The next thing is that you need to make sure that you arrange the classes, because you can see the table will have different classes. That's what will form like the rows, or sometimes they might even form the column. Make sure these classes are well defined, well arranged, and put in order. We don't want you to put it in haphazardous way that it becomes you see something first and then you see another thing. So it should be in a particular order, not just in a haphazardous manner. Let's give an example. Like if you're talking about marital status, we expect that if you are putting marital status, we don't want you to put married, then you put divorce, then you put it in a particular sequence that people would understand, okay? And then in some instances, if the data that you're trying to present doesn't have a particular order, and you can put it in any order, for example, like you're presenting data on gender, and male can come before female, or the male gender can come before female gender, it's better for you to put it in maybe ascending or descending order, okay? So, but let's look at something a little more than, that has more than two levels. Something like, let's say, employment status, all right? So you see somebody is a doctor, he's an engineer, he's a lawyer, he's this, he's that, you know. So this shouldn't come in any particular order. The order in which you should arrange it should be maybe from the highest to the lowest, or from the lowest to the highest. So it all depends on the type of variable that you are dealing with. Okay, if you're dealing with an ordinal variable, put it in that particular order. You don't change it irrespective of whether it's bigger or smaller. Just make sure you arrange it in that order. Okay. So the data also should be accurate. So when you're putting up a table, I don't expect you to put up tables and then the percentages don't add up. We expect that the data should be accurate, okay? So the data should also have all the necessary components. All the necessary components of a table should also be there, all the ones we described in the previous slides, okay? And then the next or the last thing that we expect is that the table should be attractive, because if it's not attractive, not very many people can actually understand tables. All right, so tables are not things that everybody can just understand easily like that. So, and that's one of the disadvantages of tables. These are the requirements of a good table. And then now we'll go on to the last aspect of this short lecture, which is where we talk about the types of statistical tables. So there are different types of statistical tables, but there are just basically three of them that we're going to be talking about today. The first one is something that we call a simple or a one-way table, okay? So this one-way table just has just a single variable, okay? Yeah, you'll be seeing examples in the few slides. So this one-way table has a simple just a single variable, and you can see the frequency and the percent of that variable. So it's called a one-way table. And there are different types of one-way tables where you have simple frequency tables and the rest of that. We'll talk a little about that. The next one is called a two-way table, okay? And this two-way table, some people call it a cross table. Some people call it a contingency table. Some other people go ahead to call it an R by C table, which is a row by column table. Okay, so but just understand basically that what this what this table does is that it helps us to compare two different variables, where one variable is on the row and the other variable is on the column. Okay, so and that's why it's called a contingency table or a cross table, because we want to see how one variable relates to another variable, so where the two variables cross each other, and that's why it's called a cross table. And then the final one is called a multi-way table or a higher order table. Okay, and then you see the different. It's good that you understand these different table types before we go into actually constructing tables, so that you'll be able to know exactly what we're talking about here, and then how this also helps you to do further analysis when it comes to time for data analysis. Okay, so I'll be showing you some examples of some of these tables now. The first one that you will see is the one-way table. Okay, so you can see the one-way table. It has a title. I'm sure you can see it clearly. All right, and then this table is about that fictitious study I told you about of COVID-19 vaccination status of children in Zaria in Nigeria, February 2022. Okay, I'm sure you can see with this table that this is a simple one-way table. Okay, it's a one-way table that shows the vaccination status. You can see, why do we say it's a one-way table? You can see it's only one variable that is here, which is vaccination status. No another variable, just one variable, vaccination status. We're not, when I mean by one variable, doesn't mean we cannot put another variable in this table, but what I'm saying is you have one variable is dealt with at one point in time. So we're not crossing it with another variable. So you can see vaccination status, the number of people that are not vaccinated, the ones that are partially vaccinated, and then the ones that are fully vaccinated. All right. So, and you can see it's going in that sequence: not vaccinated, partially vaccinated, and fully vaccinated. And you can see their frequencies, and finally you can see the percent. Okay. All right. So you can see also the source, you can see the stubs, you can see the caption. I'm sure you can start to see all the different parts of a table here. All right. The next table we're going to be talking about is the two-way, which is known as the crosstabs, or is also known as the contingency table, or also known as the R by C table. All right. So imagine that same data that we have now, but we collected their gender. For each child that we saw in the clinic and wanted to know his vaccination status, we also wanted to know whether he was male or female. So right now, we are putting the data for male and female on the row side, which is the stubs you can see now, and then we can see the vaccination status. So here we're seeing two variables now. Put one in the column, the other one is in the row. Please understand the difference between this and the one-way table. In the one-way table, we're just looking at one variable at a time. I think that's the best way to say it. But here, we're not looking at, you can't singly look at one variable. You see here, because you can see one particular variable is on the column, another variable is on the row, and the body, the data that you have in the body is actually talking about where those two variables intersect. So we can see how many people were males and were actually fully vaccinated, how many people were females and were fully vaccinated. So the good thing about the two-way table brings us to one of the advantages of tables that I mentioned, that it allows you to compare between the different data points. So you see, if we just looked at the data that we male, female, vaccinated, unvaccinated in this raw form, it doesn't make any much sense to us. But if we're able to put in a table now, we can now say, oh, we can see the males. The males are actually more than the females, the males that are vaccinated. Why? Why are males more males being fully vaccinated and less females are? Is it that the males usually attend the clinic more, or what is so you can now start to think about what kind of analysis you will do. And this is the advantage of putting data in tabular form. This is a two-way table, also known as a contingency table or a cross table, also known as an R by C table. Okay. So the last one we're talking about is the multi-way table or the higher order table. And here, when you want to compare three variables or more together, you can put them in a table, and this table is known as the higher order table. Now, this table that you see is not just what we're seeing here with this table is, I hope I can explain this a little for you. It's just similar to the previous table, but this time, this table has what we call a super row, okay? So it has the column, which has captions. We can see fully vaccinated and not fully vaccinated. No problem about that, right? So, but now we also have male, female, which we had in our previous stuff. No problem about that, okay? But we now divided the data also into those that were from urban. We asked also those children or their parents or their caregivers in the clinic where we collected that data, right? You staying in an urban area or a rural area, okay? So you see now we're dealing with 3 variables. The first is the vaccination status. The second is their gender. And then the third is their urban or rural status, which is their type of place of residence. So you can see that we have our primary row, which is the one that has gender, male, female, right? And then we have like a secondary row, right? I call that, or we call that the super row, right? That's the super row. And you can also have super column. And you can have super row, so as many variables as possible, you can put them in very crazy type of table. That's called a higher order table. I hope this is clear. These are very simple illustrations, and if you have any questions, please put it in the description below. So in summary, we've been able to talk about tabular presentation of data. We defined a table. I told you what a table is, what are the uses of a table, right? How you can use a table and what are the advantages of this table. And then we finally also talked about the different components of a table, different parts of a table, component parts of a table, where we mentioned that you have major ones and there are 4, minor ones are 5. In total, we have 9 of them. And when you're drawing a standard table, make sure you put in all the major ones must be there, and then any other minor one that is important should also be there. And then we talked about also the different types of tables, where we mentioned that tables, statistical tables, are basically of 3 types. You have the one-way table, which is the simple table. You have the two-way table, which is the contingency table or the cross table or the R by C table, okay? And then you have the multi-way table or the higher order table, which helps you to compare 3 or more variables together. All right. So thank you very much for listening. Thank you very much for attending this lecture. In this lecture, we've been able to tell you about tables. In our next lecture, we're going to be talking about how you can construct a frequency table. Ideally, you should use a software. You should use Excel or use SPSS, but we're going to try to do this by hand just for you to get the hang of it. And then we will now show you also how to use a software to do this. Remember, this course is not just only about you going to pass your exams. It's about you understanding biostatistics and able to use biostatistics in your life, able to use biostatistics in the field of public health, and also able to use biostatistics to help to solve a lot of problems. We have a lot of problems in the world today, but hopefully any of you watching these videos will be part of the people that helps us to solve all those problems. The quiz is in the description below. Please do the quiz. If you are a student of the DLC watching this video, your quiz is in the description below. If you've not subscribed to my channel, this is your time to subscribe. Those that have not subscribed have missed a lot of things that I've actually posted in a couple of days back, because you probably did not receive any notification for that. So please subscribe, share this video with other people also studying biostatistics in different parts of the world. Please put your comments in the description, the comment box below. If you have any questions, let me know, and I'm always ready to help. My students know me, and I'm always available. Thank you very much for listening, and I'll see you in the next one. But until then, peace.